Okay, we're going to start out today's lesson by taking a look at last night's homework. And then after we go over the homework, if you guys could hit pause, and then we'll talk about today's new lesson. All right, number one on the homework, find 3 real-life examples of a continuous variable. So anything that is continuous, and I'll give you guys a second to talk in groups about things that might be continuous, so something that's measurable. What do you think would be normally distributed? Did anybody pick shoe size? That might be something we could do. Has a normal distribution with the majority of us having an average foot and then some plus or minus an amount. And as we get further from that mean population average, we see it dwindle in size. We have a few, like if we look at our curve and we would say the average male shoe size was 10.5. Making that up, not real sure. Maybe Shaq would be way over here, Shaquille O'Neal, right here at the end. And then we might have some much smaller people over here at the other end. But shoe size would be an example of a continuous variable. And you guys can talk about those in your groups. And if you have any questions about whether you picked one that is or isn't, we'll talk about those on Monday. Just bring that back up to me. Number 2, determine whether the following statement is true or false. If it is false, explain why. The total area under a normal curve. So if we're looking at a normal distribution, are our probabilities going to add up to 0.997? No. Our probabilities are going to add up to 1. So the total area under the curve is 1, or represents 100%. Number 3, draw 2 normal curves that have the same mean but different standard deviations. Okay, so to do the same mean, the peak has to be in the same place. So we'll have it peak here like that. And different standard deviations, we might have the other one be much closer to where it peaks like that. So you're going to have one that's stretched and one that's tighter. Describe the similarities and the differences. The peak for both of these occurs at the same place. The highest point is at the same mean. But then one is stretched more than the other, and the one that's stretched out further is the one that has the greater standard deviation. Number 4, draw 2 curves that have different means but have the same standard deviations. So these curves should look identical, but they should just be at different places on your graph. So we might have one that has a mean right here, and then an identical curve, which I'm not good at drawing. There we go. That's actually not too bad. Would have a mean there. So the curves should look the same, just one shifted. So they would have the same standard deviation and different means in that way. All right, let's take a look at 5 through 8. On these, you are asked to decide whether the graph could represent a variable with a normal distribution. Ruh-roh. If we look at this one, it falls down below the x-axis. Is that allowed? No, and this is why it has a problem. Okay, is this one symmetric about a mean? No, it's not symmetric. Okay, how does this one look? This one is yes. This one is symmetric about a mean. And this one is no, because this data is skewed. And how would we say this? We would say skewed left, because the tail of the data is to the left. So this is not a normal distribution. Let's take a look at 9 and 10. If a random variable was normally distributed, approximately 95% of the population values will lie between how many standard deviations of the mean? 2 standard deviations on either side of the mean. Name the 2 parameters that are necessary to determine probabilities for a particular normal curve. What are the 2 things we need to know to be able to create that normal curve? We need to know the mean, and we need to know the standard deviation. Those are the 2 we need. Number 11, you are given the mean and standard deviation of a continuous random variable that is normally distributed. Find the interval that indicates 95% of the distribution. So 95% is how many standard deviations? That is 2 standard deviations on either side of the mean. So if we were to sketch this out, I'm going to do number 11 here. We'd have the mean, let me make it a little bigger. We'll have the mean right here at 15, and we need to go 2 standard deviations. So 3 more would put us at 18, and 3 more would put us at 21, and then back 2, so we're subtracting 6, and that would take us to 9. So number 11, the interval is from 9 to 21. So we could either write it that way, or you could just say it's the interval from 9 to 21. Number 12, this time our mean, and I actually could draw a curve over that. Number 12, our mean is at 19, so I'm going to start in the middle with the 19, and we want to go 2 standard deviations on either side, so that's plus 5, because 2.5 times 2 is 5. That gives me 24 here, and back 5, that takes me to 14. So this interval is from 14 to 24. The interval from 14 to 24. Number 13. Says in 13 and 14, x is a random variable with a normal distribution. Find the probability that x falls in the indicated interval. So if our standard deviation is 1.75 and the mean is 7, so I'm going to just sketch this out. The mean would be 7. I'm going to go back 1.75, which would take me to that lower bound. I'm already there. That's just 1 standard deviation to the left. And if I go up 1 standard deviation plus the 1.75, that gets me to the 8.75. So I'm already there. So when we're looking at our curve, what percent of the data falls within 1 standard deviation of either side? That's the 34% and the 34%. So this is 0.68. The probability that it lies in this interval is 0.68. Number 14. On this one we have a mean of 20 and a standard deviation of 0.4. So 1 standard deviation would be 25.4. 2 standard deviations would be 30.8. That's my upper bound, so I'm good. Then I go back. 1 standard deviation would give me 14.6. 2 standard deviations would give me 9.2. So this appears to be plus or minus 2 standard deviations. Well, plus or minus 2 standard deviations, we have 95% of our data, so 0.95. Okay, number 15. A box of cereal has a mean weight of 20 ounces and a standard deviation of 0.07. Determine the intervals for the values for 95%. This is plus or minus 2 standard deviations from the mean. So I'm going to do 20 plus 2 of those standard deviations to get my upper bound. And my upper bound is 20.14. I'm going to do 20 minus those 2 standard deviations to give me my lower bound, and that gives me 19.86. So the interval would be from 19.86 to 20.14 ounces. The lifespan of a battery is normally distributed with a mean of 2,000 and a standard deviation of 30. Find the probability that it's between 1970 and 230. That is back 1 standard deviation, up 1 standard deviation. So we're plus or minus 1 standard deviation of the mean. The probability is 0.68. Number 17, we have 30,000 miles is our mean with a standard deviation of 2,000. We want it between 30 and 40. So if we looked at our curve, this is our 30,000 right here. And then it's 2,000 is 1 more standard deviation. And then 2,000 is another standard deviation. So we're just here and here. This is 0.34 and this is That bell is not your bell. That bell is from the bell ringing for a class change. Okay, that's 0.135. And when we add these two together, this gives us 0.475. Okay, let's take a look at the last two. All right, this one we're going to take the probability of 0.8 times the 2,000, and this gives us 320 students. So you may be wondering where this number came from, this 0.518. It comes from adding everything that's below the second standard deviation. So if we look at the curve, if we go back and look at the curve, we've got the 0.34 here. And then the next one is the 0.135. And then the next is 0.0235. And yesterday when I went over the example, I didn't talk about what might be over here. If we do the 99.7, we have the 0.3% left, which gives me 0.0015 here on either side. Well, what I did for this one is I added up these three. Okay, this one is 0.68 times the 2,000. So that is 1,360 students. And this one is 0.16 times the 2,000. And that's 320 students. Okay, and that covers our homework from yesterday.